I've had the good fortune to see Gary King give a lot of talks, and one thing I've learned is that the person who introduces him has a terrible burden, which is trying not to cut into his talk by describing all his many accomplishments. So I'm going to just hit on some highlights that are really germane to this crowd, to computational social science in particular, but I could go on about it's probably easier to name the elected academies that Gary is not a part of than those that he is a part of, but these include, among others, the National Academy of Sciences, the American Statistical Association, and many others that I just waste our time naming. Gary has been an early mover, and indeed I think a founding figure in this field, computational social science. He's an author on many of the seminal articles. He's a pioneer in text analysis. He's created a lot of the infrastructure that we need to grow and succeed, both online and in training a cohort of really remarkable students, one of whom is our speaker tomorrow night, Brandon Stewart, but many other pioneers in the field, Justin Grimmer, Dan Hopkins, many other, Molly Roberts, many other great students. And when we first reached out to Gary, we didn't know which topic he would choose. And, he said to us, I could talk about 21 different topics. And so we thought, okay, well, how on earth do we choose? And Matt and I had a long discussion, and we went back to Gary and said, we'd really like to open it up because this is, we've assembled such a heterogeneous group, both in terms of disciplines, interests, career ranks. And so I really want to let you all guide the conversation. But in order to help Gary understand the crowd a little bit, if we could just go through and just say your name and title. I'm a PhD student at such and such a place. I don't think we have time to go over your research, unfortunately. We hope those conversations will happen over dinner. But before we do those introductions, please just join me in welcoming Gary.
Okay.
Charlotte, would you get us started? Just your name and your title.
Oh, sure. Charlotte in sociology.
Say your institution too.
At Harvard.
This is the usual thing, right? Sorry.
Hi, I'm Abdullah. I'm a PhD student at MIT in Computation Science and Engineering, and I've taken Gary's class in Advanced Quantitative Methods at Harvard.
I'm a Hiro, I'm a PhD student in sociology at Yale, and also I belong to the Yale Institute of Network Science.
They told me only Harvard people would be here.
I'm not from Harvard, I'm from UCLA. And I'm a PhD in the sociology department at UCLA.
But what's your name?
Oh, Ian. I do have a name, yeah.
Hi, my name is Moritz. I'm a postdoc at communication at the University of Zurich in Switzerland.
Okay.
My name's Taylor. I'm a PhD student at Duke. I'm Chris's student.
Hi, I'm Rochelle. I'm a political scientist and a postdoctoral fellow at Stanford.
My name is Maria. I'm an assistant professor at the Silberman School of Social Work, City University of New York, Hunter College.
Cool.
Hi, my name is Kat, and I'm a sociology PhD student at Northwestern.
Hi, my name is Rudy. I'm a demographer at the University of Oxford in the UK.
I'm Joshua, communication PhD student at UPenn.
I'm Ian, PhD student in sociology here, just crashing for now.
Elliot Ash, I'm a postdoc at the Woodrow Wilson School across the way.
I'm Anjali. I'm a PhD student in organizational behavior at Stanford.
I'm Connor, PhD student in sociology at the University of Washington, Seattle.
I'm Lisa. I'm a postdoc in political science here at Princeton.
I'm Molly. I'm a postdoc at the University of Chicago in psychology.
Hi, I'm Adani. I'm a postdoc at the Watson Institute at Brown.
I'm Tong Wang. I'm an assistant professor at the University of Iowa Business School.
I'm Ethan Porter. I'm an assistant prof at GW.
Mike Yeomans, postdoc behavioral science at the Kennedy School.
I'm Jeff. I'm a PhD student in political science at Columbia.
I'm Kevin. I'm a recent graduate in sociology at University of Washington.
I'm Bisewaju. I'm senior lecturer at the University of Cape Town.
Cool.
I'm Yo-Yo. I'm a doctoral student in demography at Princeton.
I'm Antya. I'm a research and methodologist at RTI International and adjunct faculty at the University of Nebraska-Lincoln.
I'm Anna. I'm with the Institute for Software Research. I'm a postdoc there at Carnegie Mellon University.
Martin Ilmark, a PhD student of social computing from Aalto University and the University of Helsinki, Finland.
Bo Cowgill. I'm an assistant professor at Columbia Business School.
UCA, UCA, legendary sociology.
UCA, I was sociology student when you were a student. So we have no physicists from Bulgaria. That's the only group.
More or less.
So thanks so much for inviting me. I really appreciate it. Another way of explaining what Chris said is that I sent my slides, and they didn't like slides 21 through 25. So they said, why don't you start at 26? So I thought I would just give you a few sentences about each of the topics here and just give you a feel for what it is. And then I'm happy to talk about, like any good academic, you could just point me in a particular direction and I could talk about it, but we could have a conversation about them. So this first paper with my two graduate student colleagues, Molly Roberts and Jen Pan, we were doing analyses of automated text analysis in English. And it turns out, while we were doing text analysis in English, we were developing these methods. That was our goal. We thought, well, let's see if we can figure out a way of pushing this method that we had until it breaks, right? Stress testing it, right? And that would be a good way of improving the method. We'd figure out how it failed, and then we'd try to fix it, and then we'd write this paper on automated text analysis. And we thought, as it happened, Molly and Jen both spoke Chinese. So we thought, let's go get data in Chinese, like social media posts in Chinese, and we'll try text analysis in Chinese. We'd never tried that before. It seemed like a cool thing. So we went to a firm called Crimson Hexagon, which I actually founded. And what they do is they go around the world and they collect all social media posts. They have 1 trillion, actually, as of 6 months ago. And then they use the methods that we developed previously to try to figure out what people think about various things. And so they still give me data. We went to their website and we downloaded a bunch of Chinese language social media posts, and we improved these methods. And we thought that we might write a paper that improved the method we were talking about, and we would write a paper about automated text analysis in Chinese. We thought that'd be a really cool thing. And so we work on the methods, we improve them, and at some point I said to Molly and Jen, hey, why don't you go back to the websites from which these came? Because the database came, with all these posts and the URL from which each came. And I said, why don't you click on some of those URLs and just see what it looks like, And so they came back to my office and they said, Gary, there's something wrong with the data from Crimson Hexagon. Because we click on some of the posts, it goes back to the website, looks like sort of a Chinese version of Facebook, right? And then we click on some of the other website, the other URLs, and nothing happens. Well, that's not such a surprise on the web, right? So I said, show me. So we go over to the computer in my office, and we're clicking on the posts, and we see each of the two categories, right? We see the actual Facebook-like Chinese thing, and then we see waiting, and we keep clicking, and then one of the posts we finally click, and it says, this post is being investigated. We said, what do you mean investigated? This is a social media post. Who investigates social media posts? And then we realized this is the Chinese government, right? And we realized that we had the ability to download Chinese language social media posts before the Chinese government could read and censor them. In fact, we had the entire corpus of Chinese language social media posts that the Chinese people couldn't read because they weren't allowed to, but we could. And we thought, let's forget that paper on automated text analysis in Chinese. And we changed what we were doing. Actually, that would be my main methodological advice. Change what you're doing depending on what you learn. If you write a prospectus for research and you end up doing exactly what it is that you propose, that's not a really successful project. It might be, but it's a more successful project as you realize you come across this archive that you didn't realize. And so that was this project. And we built a network of computers around the world, and we went back to each website and we pinged it to figure out whether it was still up. And we tagged each post to see whether it was censored or not censored, and then we reverse engineered what it was after. Then secondly, we did an actual randomized experiment where we wrote posts and we posted them on the web, and then we saw whether they were censored or not. And then third, it turns out the Chinese government had long been rumored to fabricate social media posts and post them on the web in the name of other people. And we thought, that's really cool, but there was zero evidence in the literature for this. And we figured out how to out all of the people doing this, and when they were doing it, why they were doing it, where they were doing it, what the purpose was, what the strategic goal of the Chinese government was, and so we figured all that out. So that's 3 things I could talk about. So if any of you are teaching or will be teaching, a project that my colleagues Brian Lukoff and Eric Mazur came up with is, the word perusal, so that means to read, but if you add an extra L, it's peruse all. Isn't that cool? .com. Which we got, nobody thought of before us. And so this implements some ideas we had about teaching. It turns out if you, as a professor, go into a classroom and you assign people teaching at some of the most august universities in the world, 20 to 30% will actually do the reading. Only half will buy the book, right? So they don't even have much of a chance of doing the reading. How do you actually get them to do the reading? So you could get them to do the reading by writing a quiz and then telling them that you're going to punish them if they don't do well in the quiz. Well, you remember way back to when you were taking these quizzes? It's horrible, right? And writing them is worse. Because writing them, you spend most of your time writing distractor questions, misleading your students. You're a teacher, like you're trying to explain things to people, and you're spending your time trying to mislead them. It's a horrible thing. It takes a lot of time. It's just ridiculous. Perusal automates all of that. It will guarantee that 90 or 95% of your students will do the reading, and they'll really like it. Okay, so you can ask me about that. And there's cool data science that's behind all of that. You have to fill out IRB reports and things like that. And have you all signed up for have you all gotten approval for an IRB thing and like taken the city test, like one of these tests? Okay, so that test, if you take the test, well, you have to take the test. You don't have a choice but to take the test. Your university makes you take this test. If you take the test, well, then you pass a certain rule they have. But taking the test causally, my claim is, causes you to do the wrong thing, right? As compared to not taking the test. Okay, so I can explain that. Our demographer. Who's our demographer? There's a demographer, and there's our demographer. You can always tell demographers, right? They stand out. Demographers. This is how I tell demographers. You have an Excel spreadsheet with tiny little cells, and it fills the entire wall. And a good demographer would walk in and say, there's something wrong with this number. Remember? They really know the data. Anyway, so we came up with these methods that forecast mortality. And there's particular problems in forecasting mortality and really cool opportunities. And so one strain of work was that I could talk about was how to make forecasts like that. Actually, it was age by sex, by cause, by country. And for each one of those cross sections, we had a time series of between 2 and maybe 30 observations, and had to forecast it like 30 or 40 years into the future, right? So if you have 2 observations, that's hopeless. But even if you have 30 observations, forecasting 30 years into the future is essentially hopeless. But if you have a lot of other time series that are adjacent to it, it turns out that they can be used to help that forecast. Because although 5-year-olds and 95-year-olds die of completely different things at different rates, 5-year-olds and 10-year-olds are very similar, and 10-year-olds and 15-year-olds are very similar, and 15, et cetera, all the way on up. So we figured out a way to put priors not on the parameters of the model, which is not helpful, because no one has priors on a parameter, because no one's ever seen a parameter, right? The only thing you see is the outcome. So we figured out how to put a prior on the outcome, or on the expected value of the outcome, and that would imply priors on the coefficients that you're supposed to do. Anyway, so we came up with these better methods of forecasting. We then went to see like the way you're supposed to, which is first you come up with a method, and then you go see where it would apply, right? Right? Come on, that's the last, right? They tell you to do the opposite, but they're wrong. Okay. If you're a surgeon, you don't first come see the patient and decide, well, wait a second, should we do yoga or surgery or give you chemistry lessons, right? If you need surgery, you want to go to somebody that only does that, right? And then that person should go see where that person is useful. Anyway, side speech. So one place we realized that was making mortality forecasts was the United States Social Security Administration. In fact, it was pretty much required in the law in the 85-year history of this program to make forecasts. They've been making forecasts so long that the year that they forecast actually was realized, and we can actually see how well their forecasts did. And so we first collected all of the forecasts that they made and looked at all of the evaluations they did of the forecast. They made a lot of the forecasts, The evaluation of the forecasts are written on the bottom of my slide there. You can see it, right? There are none. They never evaluated their forecasts in 85 years. And so we thought, let's do this. And we wrote this paper which compared the air forecasts to the truth. And we used this method called subtraction. And it was really cool, the results, because they forecast about average, unbiased, about right on average until about the year 2000. And then all the different forecasts they were making all veered off from the truth. And they all veered off in the same direction, making the Social Security trust fund look safer and healthier than it really was. And then we figured out why that was the case. So that's, let's see, do I get to, I'll just make believe there's a red dot here. No, I don't need it, that's okay. I'm just making jokes to myself and enjoying it. Okay. So I don't know if you know about this paper in this work in psychology. So this is the fifth biggest scientific breakthrough of the year, according to Science Magazine, decided that psychology, or pretty much social psychology, is a disaster because nothing can be replicated. And we figured out that and they actually did this Herculean thing of replicating 100 experiments from scratch, not from the data. They redid the experiments. And they showed that a minority of them could be replicated, and that threw into question basically all the results of this entire field. Sort of devastated a lot of people and their careers. We asked the question, well, how many of them would replicate just by chance? Like, how many would fail to replicate just by chance alone? Right? And the answer was about the number that failed to replicate. Okay, so I can tell you about that. That didn't make them very happy. But that's okay. They didn't make almost anyone else happy. Some of the talks I heard as I walked in earlier, and I'm sure some others here, and pretty much anybody that does text analysis, doesn't always start with a data set that includes everything, right? Those of you who are analyzing Twitter, right? Twitter and is, and social media is filled with, things like cat videos, right? You're not interested in cat videos probably. And so first thing we want to do is weed them out and then get a flow of some Twitter posts that we're interested in. And we could study those. And how do you do that? With keywords, right? And so humans choose the keywords, right? We choose the keywords. We pick the keywords, that narrows it down. It turns out that human beings are really deeply, horribly bad at choosing these keywords. Okay, I don't mean other humans, I mean you. Okay, that is, if you sit down and you come up with a list of keywords that mean a particular thing, you will leave out most of the keywords that thing means. Okay, like you're really bad at this, like way worse than you think, and I'm not talking about the other people, I'm talking about you and me, okay? There's a well-known psychological process that I could describe that's surprising, and it literally causes us, it's literally inhibitory processes in our brain that cause us to not remember things at particular moments, and this is one of those moments. And so we came up with a computer-assisted way of helping us come up with keywords, and we can do demonstrably better. So I can explain that. That might help your text analysis. Do you use robust standard errors? You know what robust standard errors are? I'm not asking you to admit something. Okay? So robust standard errors have been used in 79,800 articles, according to Google Scholar, as of a couple months ago. 79,000. You know what? That's wrong. I just conflated two different papers. Actually, it's like 54,000. But anyway, those are basically the same number, aren't they? This is Molly Roberts, the same person, one of the same people that was doing the first one. And I wrote this paper. And the point here is that robust standard errors are great, right? Because if you make a mistake in your model, that sometimes causes the standard errors to go wrong, right? And if you make, just a little bit of a mistake and you correct it with robust standard errors, that can fix up the standard errors. But what you're just doing, if the robust standard errors are actually different than the actual standard errors, you're admitting to everybody, including yourself, that there's something wrong with your model, right? And if a little is wrong with your model, you've just fixed it up. That's all good. But how do you know a little is wrong with your model? Like, it's to me like your model's wrong. So like, let's go fix the model. So if you see an article with robust standard errors on there, and they differ, and they're the same as the classical standard errors, then what are they putting them there? Okay. But if they're different than the classical standard errors, they're publishing a model and expecting you to read a model that is wrong. Why? Why don't you just fix the model? Okay, so that's what that paper's about. Let's see. I can keep going. Should I keep going and tell the rest of the story? Okay. Okay, so do you know about multiple imputation for missing data? Okay, so just to fill in everybody else, so if you have missing data, when I was in graduate school, I ran a regression the first time, and the result, and I remember this, and well, actually that's an interesting and important fact. I still remember that. Okay, but the other thing was I ran the regression and I tried to interpret the coefficients, and they didn't make any sense. And I traced and I traced, and I finally realized that the missing data were coded as -9s, and those -9s were actually numbers, and the regression was using the -9s. So that was wrong. So then I tried to figure out, well, what do you do about that? So I opened up my statistics book, and there was nothing to do. It didn't say anything, right? And so I opened up, of course, the manual for how to do real statistical analysis, the SPSS manual, and I look up in the back, and I look at -9, and finally found missing data, and what it does is listwise deletion. So you put in a code that says missing -9, and that's all, and then V4 -9, right? And so it takes any -9 and recodes it as missing data. Great. And then I run the regression. I didn't really know what it was doing, but I ran the regression. And what happened was it said, sorry, you don't have any data. And I thought, well, what's going on? Okay, so that meant that pretty much of any row in my data matrix, there's like one missing data, let's say, and one missing element, and all the rest are observed. Okay, what does it do for that row? It just deletes the row. Right? That's listwise deletion. Okay, so it just threw away all this incredible information. Okay, so what did I do in graduate school? Well, obviously you can't throw away all your data and do an analysis. That's called theory. Okay. So what are you supposed to do? Well, okay, so people who answered the partisan identification question, who refused to answer that, who refused to answer the partisan identification question, obviously they're independents, right? Let's go with that. Okay, so you put that down, right? So you make inferences like that, and you fill those in, and then you can run the question, which is a little arrogant, right? Because you don't get the answer from the respondent, so you make it up for them, right? That's what we do in academia, right? We try not to. Anyway, so multiple imputation deals with that problem in a much better way, because obviously, even if you guess right, you're overestimating your uncertainty. Or underestimating your uncertainty. So multiple imputation says, let's get the uncertainty right. There's a particular model that you use to impute in the best possible way, given all the data you have. Impute means make up, make up the missing data. And then to reflect the uncertainty, you take, instead of your one big data set with rows and columns, and you put it here, and all the holes in the data set, like Swiss cheese, you fill it in with the imputations. And then you go here, and you create another copy of your data set, and the holes are filled in with imputations too. And when you predict really well, when your model predicts really well, it fills in the holes with almost the same value. When the model says, these particular holes we can't predict well at all, it predicts the imputations with very different kinds of values. Right? So the uncertainty is reflected. Then the really cool thing and the wonderful thing is you run, and you do that like 5 or 6 times, then you run whatever statistical model you would have run. You just run the same thing 5 or 6 times, and there's a particular way of combining the results. So it's a very convenient procedure. You get to separate out the analysis model from the imputation model, and you sort of fix the missing data. Okay. So we thought about this, and we said there's a lot of, what about data, basically there's 2 kinds of cell values here. There's ones we know actually completely and totally, and then there's ones we don't know anything about. But actually, that's not true. Neither of those are true, right? The ones we don't know anything about, actually we have some idea about them. We just don't know the answer, right? The ones that we observe the number, I mean, to say that we know that exactly, like in the social sciences, really? And a lot of these variables have more measurement error than others, and some of them have quite a lot of measurement error. And there are plenty of procedures for for measurement, for dealing with measurement error in the social sciences, but they require all kinds of assumptions, and they're actually not used that much in actual real articles. So what we did is we realized that the observed values that are measured with error in this same data matrix, we could treat with the same kind of technology as multiple imputation. And we call it multiple over-imputation because we overwrite the observed values with our model, and it helps correct for measurement error. So one thing to do if you're trying to publish articles and make a place in the world is take an article where they use list-wise deletion, use multiple imputation, and you might come up with different results. But in addition, now that we have the measurement error piece, is if you recognize there's measurement error and you have some knowledge of what kind of errors there are, like economic data may be measured better over time, or we have data which is based upon samples from different parts of the country, and some of the samples have large numbers of people and some of them have small numbers of people. And so the ones with small numbers of people would be more variable means than from the large numbers of people. We can use that information to multiply over-impute. And there's software, it's called Amelia, which is named after that famous missing person. Well, that was pretty good, wasn't it? And so it does all that. Let's see, there's a paper I don't know if you're getting windburn, but
we did talk about this paper this morning.
Oh, you did?
Does everybody remember the variable to Google flu? So can you skip that one, or yeah, do you want to hear more? Okay, yeah, maybe skip that one if people want to bring it up.
I'll tell you why this happened, so you know what the story is. So why this happened? I talked to people at Google afterwards, and they were actually sort of happy about this paper, which I'm sure Larry and Sergey were not particularly happy about it, but the data people were very happy about it because basically the people that came up with the idea to do Google Flu Trends were inside Google, and they set up their machines, and it was doing a good job, and then they left the company, and the machines kept running. And 3 years later, we came along to do our analysis. That's literally so. Okay, so I wrote a paper. It was longer than this title, but I couldn't fit it on one line, so I abbreviated it. It's called Restructuring the Social Sciences, A View from Harvard's Institute for Quantitative Social Science. And so we created a big institute there. Maybe that's not of interest to this group, but it made it to this page. Let's see, so I was working on two thoroughly unrelated projects that turned out to be the same project. Okay, so first of all, for the World Health Organization, they're actually, I'm going to talk about death and I'm going to talk about social media data. Okay, so let me talk about each of these two things. Those are basically everybody's two favorite subjects, right? Okay, so the first question is death. So what the World Health Organization wants to know is what people are dying from, what the causes of death are in developing countries. And in most of the world, in the U.S., when somebody dies, there's a death certificate, right? There's some medical personnel observes the body, maybe does an autopsy, maybe does some medical tests, and signs a death certificate, says it was lung cancer, right? And then all these are collected and sent to the National Institute for Health Statistics, and they're aggregated up and they do an analysis. In most of the world, what happens is people go off to the bush and are never heard from again, and that's it. And those are the places where we really need to know what people are dying from, because those are the places where diseases could emerge and spread really fast, and they might even get back here, right? So we really need to know what people are dying from in places without vital registration systems. So how do you figure that out, right? Well, you could do a survey, but these are dead people, right? So how do you actually, and moreover, you can't do autopsies. It's typically culturally prohibited in most parts of the world. So how do you actually do this? Well, one way that people do this is a verbal autopsy. That's not causing the dead people to talk. But the way it works is you do a random sample of households in which someone died. And you speak to the next of kin, and you ask the next of kin some uncomfortable questions. Did the person who died have real bad stomach pains? Did they look all yellow? Did they, and you're trying to elicit the cause of death, right? Did they have tire tracks across their back? Right? If nobody laughs, we're going to get the laser reinstalled here. Anyway, so you ask these questions, and then you show the answers to a physician, and the physician says what the person died from. And then they did that for a long time, and then some smart aleck said, wait a second, let's give the answers to a second physician. And the second physician gives you a second cause of death, which is not the same as the first. And the third physician gives you another cause of death. And the physicians in this context were totally useless. So what if you got a really good physician, somebody from this area, who really was the top doctor in the area, sent them to Tanzania and had them do the thing? You would do worse. Why is that? That's because the priors of the doctors from New Jersey, when they see sniffles, they don't think malaria. There have been 0 cases of malaria in I don't know how many years in the whole United States, right? So their priors are all messed up. They would do worse. Well, why don't you just take good doctors from Tanzania? Well, because to do our little study, there aren't enough doctors in Tanzania. We would be killing people just to do the study. So we figured, let's try to automate this. This has been attempted. Yeah, and how would you do it? Well, you go into a local clinic. In a local clinic, there's a bunch of there's people that that die, right? And you get to see the body because the person dies in the clinic. And then there are medical people, and so you get a training set. You get labels, right? You should figure out what they died of. Different people make it to the clinics. So there's all kinds of methodological issues, but you have a training set. Then you can go to the community. And in the community, you only have the answer. Oh, sorry. You take the people and you get the training set. You know what they died of. That's the outcome. And then you can trace them back to their community, back to their household. Ask the next of kin there the same series of uncomfortable questions, and that's your training set: the predictors and the outcome. And then for everybody in the random sample of deaths, you only have the answers to the survey questions. You see and you fit a model to the first one, and you try. Only the problem is the models did really badly. Right? And why did they do really badly? They did they did badly because they don't really know what causes what survey questions predict death, right? And so we worked on this problem. Okay, Ying Liu, who actually was from Princeton, from the Center for Population and Demography. That's what it's called, right? The Center for Demography. What is it called? OPR. OPR. Nobody's ever going to tell me what O stands. Office. Sorry. So anyway, we worked on this problem. And we came up with a solution. And what we realized was, in public health, no one cares about you. They only care about everyone. They don't care about any individual classification. They don't care about making a mistake about any one person's death. They only care about the percent of people that die from stomach cancer. They don't care whether you died of stomach cancer, right? If you're sick, go to a doctor, not a public health person, right? They'll care about you, right? And so we realized that the objective function of these classifiers was not what we cared about. Because our objective, or the objective of the World Health Organization, was to get the percent in the category correct, regardless of the percent correctly classified. See that? Those are 2 different things. Let me just explain that again. So if you classify every individual death correctly, you add them up, you get the percent in the category, no problem. So everything's fine. But if you don't get everyone correctly classified, and you won't, then when you add up, you'll get the wrong percentage. Okay? Now, what happens? So classifiers are incredibly greedy, because what they're trying to do is they're trying to increase the percent correctly classified. My example for political scientists is take all pairs of countries since World War II every year. There's about 1 million of them. And then you try to predict which pairs of countries for each year are at war. Okay? So there's about 1 million pairs of countries. There's about 1,000 that were at war. A really good classifier, according to the classifier, is there's never been any war, there never will be any war. You'll be 99.9% correct. Totally useless. See what I mean? Right? So it's just optimizing the wrong thing. If you're trying to estimate the percent that are good of country pairs that are going to be at war, that's a useless number because it's optimizing the wrong thing. So we realized that what everybody was trying to do was optimize the thing for the medical people, whereas what we really wanted was for the public health people. So once we knew what we were after, we changed the method to optimize the percent in the category. Our method did not produce good estimates of individual classifications. In fact, it didn't produce any estimates of individual classifications. It only estimated the percent in the category. Okay. So we'd worked on this. We basically, for our point of view, we'd solved this problem, by which I mean we were able to write a paper on it. But the World Health Organization uses this all over the world. Okay. So for a year, back up, Dan Hopkins and I, he's now at Penn, he was a graduate student, we were analyzing social media data. And we thought, hey, let's, well, actually back up. So the political scientists in the room will know that political activism is a very important thing to political scientists, because if you don't have people pursuing office, you don't really have a democracy. It's really an essential thing. So political scientists study political activism, right? It's a really important thing, okay? There was a very famous book written by Sidney Verba, Henry Brady, and Kay Schlossman, in which they went and they studied political activists. Now, how would you do that 20 years ago? Now, 30 years ago. How would you do that? Well, you take a random sample of the United States population. They took 15,000 people, and they asked some screener questions and weeded it down to maybe the 2,000 that were actual political activists, asked them some detailed questions, and then they wrote a very famous book, 2,000 people. And we thought, at the time, what was called the blogosphere was, they were like supposedly, I remember early on, there were supposedly 40 million blogs, not even blog posts, but blogs. Now there's almost 700 million social media posts a day, okay? But anyway, we thought, gosh, there's all of these people writing, and a large fraction of them are about politics, basically, right? So we thought, we'll just use the methods that the computer scientists have for natural language processing. We'll figure out how to download all this stuff, and we'll write this great paper and have way more information than our colleagues who wrote this very famous book. And we figured out how to make this contraption to download all this data, and we just tried these natural language processing methods, which of course were an utter disaster. They just did not come anywhere near close to anything accurate, which we knew because we would hand code the posts. What were we trying to do? Well, this was the 2008 presidential primaries of Obama versus Clinton. Hillary Clinton and Obama were running against each other. We wanted to know what people thought about each of the candidates. So one simple thing was a blog post which was extremely negative, neutral, positive, extremely positive about Hillary Clinton, let's say. Okay, and so we wanted to take each post and put it into each of those categories. Okay, and none of the methods of automated text analysis came anywhere near close. And we literally tried this for a year. And we'd be mining the literature, and I'd come in one day and I'd say to Dan and our merry team of undergraduates, hey, we have this new method, this is going to work, and they're like rolling their eyes at me because they've been at this for 10 months, like nothing has come close to working. And when we keep trying this, until one day I realized that these two problems I was working on, which seem like completely unrelated, deaths in developing countries and social media data, they're the same problem, right? Because remember I said in social media data, nobody cares about you, they only care about anybody. In social media data, nobody cares what StatPumpkin222 says on Twitter, right? We only care what everybody has to say on Twitter. So it's actually the same thing. We only care about the percent in the category. We don't care about any one post. So we literally use the same code to solve the verbal autopsy problem as and poured it over to use for social media, and so that was that actually. So that's a long story. I feel like there should be some kind of transition, like maybe like one of those PowerPoint things where at least things slide in, okay, I'm not going to stop. So also for the World Health Organization, that's how these two got grouped together, they were doing surveys in 80 countries around the world. And they would ask questions, the same question in different countries, and expect to be understood by people in different countries, and you get back the answers. Of course, it's actually way more difficult to write survey questions that people actually understand than it seems. I actually think survey research is, which I do, is one of the most arrogant professions, because we think we can just write a question that is just very clear that no one will misinterpret, right? But yet, when we go home, never ever have misunderstandings with people we've known for 20, 30 years. Right? Really, so it's actually extremely difficult. Okay, now, let's multiply that by translating it into a whole lot of languages, sending it out all around the world to many more than 80 different survey teams, having them administer the survey in all kinds of different surroundings. You know, one thing we had an eye test where, you know, you hold over your eye and there's E's pointing in different directions, right? And in some places it's like this room, and in other places there's like dust flowing by and there's no light, and, you know, like getting things so that people understand what you're talking about, it's really difficult. Actually, a side point, I'll tell a side point story. So we translated actually no, let me tell this, sorry. Excuse me while I just tell stories to myself and enjoy it very much. So the question was, how do we make it so that different people in different cultures could understand the question in the same way, or more likely, we could at least understand what they intended. And we came up with a solution. It's called anchoring vignettes. And this came up, in particular, I'll give you this particular example. We asked people in China how much say they have in government. A lot, a little, etc. Right? So how much say do they, believe me, in China, they don't have any say in governments, okay? In elections or things like that, okay? They put themselves about here, let's say. We asked the same question in Mexico. Mexico's a democracy. Not the same democracy as we have in the United States, but like they defeat candidates and things like that. Incumbents lose, okay? So how much say do they have in government? The truth is, you know, up here somewhere. The answer was here, okay? Why does that make sense? The Democratic Mexicans put themselves here. The Communist Chinese put themselves here. It doesn't make any sense. Why is that, okay? You know, you quiz people, you try to figure it out. I think what the answer is in the social situation of a survey, people use the whole scale. And we were trying to apply the whole scale to different cultures. And they're trying to give you something. By trying to give you something, they blow the whole survey, right? You know? And so we needed to put these on the same scale somehow. And so the way we experimented with 1,000 different ways, or a dozen different ways, but what we actually came up with was the following. What we would do is we would ask the question exactly as I described, and then we would ask a vignette. We would describe a hypothetical person. So suppose the question is how mobile somebody is. We would ask the question, how much trouble does, we would describe a hypothetical person, let's say Allison. So Allison can walk up a flight of stairs, but she feels breathless when she gets to the top. And we would ask the question, how much trouble does Allison have getting around the house? And then we'll ask the question, how much trouble do you have getting around the house? Now, if you put Allison here, and you put yourself here, that says something. Even if in your culture, you know, this is what the threshold is, right? I mean, the real problem is that if you say, how healthy are you? Excellent, good, fair, poor, which is the main method of figuring out whether people are healthy in public health. And you ask one of you, and you had a cold, and you twisted your ankle after you came back from a run, and I said, how healthy are you? Excellent, good, fair, poor. You might say poor. But if we visit a 90-year-old man by his bedside, and we say, how healthy are you? Excellent, good, fair, poor. He might say, excellent. All his friends have died. You know, he's real happy to be around, right? And it's crazy to think that he's healthier than you are, right? So we ask the same question of Allison. And once we know Allison is the same in your culture and my culture. We know that because we created Allison. We can do that at Harvard, okay? We created Allison. Allison is one thing. As long as we understood what there's plenty of assumptions in it, all of which are laid out. But Allison provides that's what a standard of measurement is, right? Okay, now I'm going to tell this other story just because it was really cool. Okay, so one of the vignettes was how healthy is this person who could run 10 kilometers. We had another vignette of how healthy could this other person be, or how healthy was this other person who could run 5 kilometers. Now, in every culture in the world, the person who could run 10 kilometers was healthier than the person who could run 5 kilometers, except for sub-Saharan Africa. Okay? In sub-Saharan Africa, if you could run 5 kilometers, you were more healthy than the person who could run 10 kilometers. Why in the world was that? Okay? Why is that? So we translated it again. We asked the question again, same answer. We translated it and translated it back, same answer. We did all of the best practices in survey research. Finally, we just said, okay, you two get on the plane, go. Okay? Talk to those people. Either find out why they're doing it or tell them not to do it anymore. Okay? Anybody want to guess what the answer was? I'll give you a hint. Okay. If you're going to run 10 kilometers in the desert, you must be deranged. That was the answer. So if you're only going to run 5 kilometers, they just didn't have the idea of like running. You're going to run? What, who's going to run 5 kilometers or 10 kilometers? Well, 10 kilometers must be worse than 5. That was the actual answer. Right? So it was like that's survey research. Okay? With a bunch of researchers who spent like several years figuring out interpersonal incomparability. Okay. Okay, so field experiments. This is a really huge opportunity. We've figured out how to evaluate large-scale public policy programs, run big field experiments. I can talk about 2 field experiments, one in Mexico, where we literally randomly assigned, like I flipped coins, and heads, it was more sophisticated than this, but heads, your community, which had never received healthcare before, probably in history, we build hospitals. We built you hospitals, and we brought in drugs and medicine and doctors and nurses and money to pay for it all, and insurance. And tails, you don't get healthcare for at least 3 or 4 years. Okay. So that was a high-stakes experiment. Run across the whole country. The Mexican government signed papers with us that they promised to implement whatever program we designed. That was a big political. Getting that to happen, I think, is a lot of the story. I could tell that story. We figured out ways of the biggest problem in public policy evaluation is the politicians that made it possible to do the evaluation, because politicians in most large-scale evaluations intervene and mess up the evaluation. Okay, at least most published ones, right? Like the experiment before the one we ran. The governors of some of the states in the who were states in control groups found enough money in this anti-poverty program to give the anti-poverty program to the people in the control groups who weren't supposed to get it in the experiment. You know, they got tails instead of heads. They found enough money at the last minute just to give them, right? Isn't that a great thing, right? And, you know, as researchers, we can't be outraged that they're ruining the science, right? These are democratically elected politicians. That is their job. If they want to optimize over the short term instead of the long term, who is it us to say? So we had to come up with methods that made it possible to make valid causal inferences even when politicians intervene. So we have methods that are, you know, the term statistically robust. So we wrote an article about our methods being politically robust. And then there's an experiment on media effects, which is not published yet. Just don't tell anybody, okay? It's not public yet, actually. So everybody wants, or everybody in this field of media effects wants to know the effects of the media. We all think it's big, okay? But let's think about this, right? What is a media organization? They're not actually trying to change your opinion. They're actually trying to stay in business. Right? That's what they are. They're businesses. And if you go in a particular direction, they're going to follow you. Right? That's what they do. And if they don't follow you, they're going to go out of business. Right? That's big. So the cause goes from people to the media organizations, but yet what most of us social scientists care about is the cause that goes from the media organizations to the people. So how do we break that endogeneity? Right? Well, we call it the New York Times, and we tell them what to publish, and then we see what the effect is, right? Okay, that's a little difficult to do. So what do people do? Well, there have been a lot of incredibly creative analyses. They put up a TV tower for the first time. There's a hill over there. The TV tower goes this way. There's a radio shadow of people that don't get TV and people that do get TV, and you can compare the two. And you think, well, that's pretty good, unless the people that live behind the, they're somehow different from the people not. There's all kinds of creative ways around it. But what we really want to do is call up the New York Times and tell them what to publish, right? Okay, so what did we do? Well, we didn't call up the New York Times. But we did negotiate with 51 media outlets. You would have heard of some of them anyway. And we convinced them to let us experiment on them. And so we chose a policy area. We chose a subject with them. We chose by random assignment when they would publish the article, and we ran this experiment. So in fact, we even simulated what's called packed journalism. You know, if you've ever heard this term. This is the idea that you notice when the New York Times publishes an article, the Wall Street Journal and the Washington Post publish. You know, if the New York Times scoops the story, right? They're the first ones there. Then everybody else follows along. It's like the opposite of what we do in academia, right? We're all trying to stake out our own turf, right? Unless we can show the original ones wrong. Well, they all sort of go together. And so we actually simulated that. So we took a group of people, we had them collaborate with each other. They all published at about the same moment when we flipped the coin and said their code. Anyway, the effects are really huge. But that's coming, that's secret. And then there's other stuff that didn't fit on the page, so I put them all in the list. And maybe I'll just list them instead of tell you about it. Ecological inference, which is making inferences about individuals when you only have data aggregated up to some area or other unit. I've written about qualitative research, designing social inquiry. It's a book on this. I like the subtitle of that book, which is Scientific Inference in Qualitative Research. Rare events, forecasting mortality, which I mentioned, forecasting presidential elections, which is not difficult, not hard to do. We've done it. That is, we can forecast how almost everybody's going to vote, but if our forecast is 50% plus or minus 3%, that doesn't tell us who's going to win, okay? But nevertheless, like, I would have been willing to bet you my house that neither candidate was going to get 75% of the vote, or even 60% of the vote, right? So we actually know a ton about that. Also, forecasting international conflict I've worked on. The methods used to evaluate legislative redistricting, redrawing district boundaries, I came up with a number of different colleagues. That's fairness to political parties, and also ecological inference is also used in that context because the law requires you to figure out whether blacks and whites and Hispanics and Asians are voting the same way. And the law also says that there shall be a secret ballot, and you may not know the answer to those questions. So you have to do it by estimation. That's what we do ecological inference for. And I think the last thing I have listed here is Dataverse, which is one of several big open source projects. This one is for data sharing, and there's a number of others as well. Anyway, I could also keep telling stories, or we can talk about one more in depth, or I could take a sip of water.
Before we do that, let's let him take a sip of water and just join in. So we've got roughly 21 topics on the agenda. The only thing that I can think of that Gary didn't cover is his off-road unicycle skills. You think I'm kidding, but he actually does that. So feel free, maybe that's a dinner conversation, but to get us started, does anybody want to jump in with one of these many great topics here?
There's something else that we think of.
Bo over here.
Well, I was going to ask a question that's not on here, but
that's okay.
I'm curious. What do you like and dislike about the way economists do empirical work? And related, what do you think are the most kind of underrated ideas in causal inference?
So what do I think? So you're asking for an ethnic slur about the economists, right?
No.
Effectively. So economists are, each of our disciplines have different interesting cultural norms. So economics, everybody sort of works on, roughly speaking, a very small number of things, and they do it in very much the same way. This has advantages and disadvantages. So the advantages are that they do more science. And what do I mean by that? I don't mean they're more scientific. What I mean explicitly is that science is not about individuals acting scientifically. Science is about a community of people operating in cooperation and competition in pursuit of the same goals with a set of rules. Like, if I can convince everybody that something is wrong or the status quo view of something should change, and the change is big, the bigger it is, the more credit I get. If I can convince people that smoking is really good for you, I become one of the most famous scientists of all times, right? So so those rules of science, that's not a small thing. That's like how society made almost all the progress it's made over the last 400 years. It's a big thing. And that involves a lot of people working on the same issues. So the economists, unlike the other social scientists, really have that. However, what they have by all doing that is they have high mean, because they're all doing the same thing, but they have really high variance, because they're all doing the same thing. And the same thing could be wrong, right? So like the last generation, I used to describe economics as divided into two categories, theory and theory. There was game theory and econometric theory. That's pretty much all they did, right? Now they do some theory, but they basically decided, oh, you know, all that game theory stuff we did, that's not really right. Some of them still, I mean, of course they still do that. But they've gone and now they've invented behavioral economics. We call that, you know, sociology, psychology, social science, something like that, right? But even so, it's true. Even so, when they do that, they follow particular rules, which are great and important and valuable. Like they run every possible alternative regression. They only use a specific set of techniques that is authorized by the econ gods. and they work on a very specific set of questions. So I like the field. I've occasionally worked in things like that. The Social Security paper was economists. We published two papers. One was titled Bias and Non-Transparency in U.S. Social Security Administration Forecasts. And then on the same, and that was published in the Journal of Economic Perspectives. And then on the same day, in Political Analysis, we published explaining bias and non-transparency in U.S. Social Security Administration forecasts. So we arranged and managed to both publish on the same day. Anyway, so that's my thing about economics. When it's appropriate, when they're doing the right thing, it's really, really good, and they're incredibly careful. But you know, a novel form of data with a novel kind of statistical method is, you know, they may do that, and when they do it really well. But you're less likely to find it there. And let's see, what was your second question was?
Most underrated method
idea
or
and causal
approach.
inference. I would say maybe post-treatment bias. Like I think people should have that on the tip of their tongue. I was on the editorial board of I never remember which sociology journal it was. It was one of your three-letter journals, you know, and I'd say that was in most of the papers. Just like in political science, most empirical papers in international relations and comparative politics have the problem of post-treatment bias. So I'll just explain for the people who are making believe they know. So you shouldn't control for the effects of the cause. Okay. So if you look up in an econometrics book, often this is not mentioned at all. When do you have omitted variable bias? This is what the description is. The econometrics book says, I took econometrics from Art Goldberger. A course on econometrics is the economic book at the University of Wisconsin. One of the best courses I've ever taken. Anyway, you look up in this book for omitted variable bias. What are the rules? You have omitted variable bias when the omitted variable, you've omitted it from your regression, and it is actually related to your treatment variable, and it is related to your outcome variable given the treatment. Okay? When those two things happen and you omit the variable, you have omitted variable bias, and so you got a problem. You better measure the variable and control for it. Okay? Here's my counterexample. Okay? So that's in there. It was in all the econometrics books. Here's my counterexample. My outcome variable is who you're going to vote for. My treatment variable is, let's say, whether you're unemployed or not. Okay? And you know, maybe if you're unemployed, you might be more likely, let's say, to vote for the, who knows this year, probably the Democrats actually. Okay. So, and then here's my question: should you control for your voting intentions 5 minutes before you walk into the voting booth? Well, your voting intentions 5 minutes before you walk into the voting booth is certainly related to the outcome, who you're going to vote for. And it is certainly related to unemployment if unemployment actually predicts the outcome. So you should control for it. If you control for voting intentions 5 minutes before you walk into the voting booth, then the effect of unemployment on voting is going to be zero, right? So something's wrong. And that's post-treatment bias. You should not ever control for anything that is a consequence of your cause. And that's a real bummer, because if you're looking at the effect of the of being a democracy versus an autocracy on international conflict, let's say, should you control for GDP? Well, GDP is causally prior to whether you're a democracy, because you'd be more likely to be a democracy if there's lots of money. And it's also a consequence of being a democracy, because if you're a democracy and there's freedom and stuff like that, there might be more economy. So if you control for it, then you have post-treatment bias. If you don't control for it, you have omitted variable bias. That's bad. That's my most underrated problem. Fix that problem, yes.
So I love the breadth and diversity of the topics. And I'm wondering if you could speak a little bit about when you're deciding which topic to pursue, what do you consider, what motivates you, or what compels you to choose a particular topic? Particularly, and can you also, and I don't mean to put you on the spot, but can you also think about topics that didn't lead anywhere, right? Like which topics you thought were great, but ultimately were sort of failed investments?
Oh, sure.
Yeah. And how you just think, and might you be able to sort of anticipate that in advance?
Yeah, so failed investments, often they're just pass you don't take, right? Like the first story I told, we were going to write a paper on automated text analysis in Chinese. Like, I think that would have been an okay paper. I think it would have been a good paper. I would have enjoyed writing that paper, but we found something more fun. I think that's sort of what happens, right? It's sometimes you have a hypothesis, you test the hypothesis fails, you don't have any other ideas, and that's it. And then that directly answers your question because there's a failure of the hypothesis. But I think that the way I interpret it, for me anyway, it's a failure of my creativity to think of something else to do with it that I care about. So that's the thing. And I'd say the most underrated methodological tool is changing the question. Like, somebody asks you a question and you just change, and you can't answer the question, just change the question. It's okay, you're allowed, right? And so I don't ever admit to failure. I mean, so you asked me two questions. What do I choose to work on? I'm interested in a lot of things. When I was in graduate school, my advisors would say the worst thing you could say to a graduate student, which is, you're scattered. You're working in this area, in this area, in this area. And I said, no, I'm doing methods. That's what it is. I'm doing methods. And they said, there's no such thing as methods in political science. You're scattered. But I just kept working on all these different things, and I kept saying, no, I'm doing methods. And then I knew I won at one point when the faculty member turned to me and she said, wait a second, Gary, I get it. You're not scattered. You're a methodologist. You're narrow. And I said, yes. And then I got to do whatever I felt like doing. So I would love to work on all kinds of different things. I mean, there's so many things to be interested in, but you don't get the chance. In fact, that's the end. So yeah.
I have a couple of questions. The first one is, so you talked a lot in some of these projects about sort of an explicit goal being forecasting or prediction. And then, of course, you have one paper which is using social media data or like Google search data for prediction, and exactly critique paper, like the Google flu paper. So I was wondering if you could sort of talk about, people like Halvarian talk a lot about nowcasting and things like Google. And I was wondering if you could talk about sort of the problem of forecasting or trying to do some sort of prediction with social media data or some sort of web data. And whether you think there's still any merit to that, even after the Google flu fiasco. And the second question I want to ask was probably more to do with your Chinese censorship project. And then I know you said that it draws on your work for the sort of algorithm behind Crimson Hexagon. And I wondered if you could probably talk a little bit more about what exactly is going on. So are they sort of trawling or just scraping a lot of information? And just sort of like so that we can understand a bit better what's really sort of the data behind it and what kind of data collection is behind it. And the third thing is more practical. Question, which is just how, so for young people, I mean, there's enormous breadth here and it's very exciting. How do you sort of recommend prioritizing skill development when you're relatively young, so that 20 years down the line one can also sort of do exciting a wide range of projects?
So Google flew Crimson Hexagon and skill development.
Yeah.
Skill development is the most important. Do that, right? Like in political science, you could take a class on, I don't know, the American presidency, or you could go take another statistics or computer science course. Do the latter. Okay, I've taught the former, but the fact is you could read the former, right? You could read the syllabus on your own. It's really hard later on to get new skills. Okay? Empirically, the vast majority of people who graduate with PhDs spend pretty much their whole career using the methods they learned in graduate school. Now, you'll be different, okay, or try to be different. Try to remember that. You're in a profession in which you get to learn. Learning is actually the thing we do. Teaching is the thing we do, so try not to do that. But, you know, the fact is a good way of forecasting what you are going to want is what other people who are like you actually did, and that's what they keep doing. So what does that mean? That means to get the best skills, the best time to do it is, you know, right now. Like the younger you are, like that's when to get it. So yeah, absolutely. Okay.
How do you decide which skills?
Oh, which skills? You know, I tell my students that you want the skills. You want the skills so that you can beat those people at Princeton. Right? Right? You don't know, and we don't know that. We don't know the answer to the question. And you know, like I don't know. When I started, it was basically like how much statistical skills could you get, and now also you want computer science skills, right? And there's going to be other skills too. But so you want, you know, there is no. I mean, this is an excellent question, and like all excellent questions, there are no answers to this question, right? But another way to pose the question anyway is, what's going to, you know, you want to know what everybody else knows, but then you want some angle that's going to get you something else, right? So maybe you have some form of data that's going to be different, right? I mean, I think that's the kinds of diverse areas that you're all from, and interesting projects that you're all working on. You could pick up another project that would have another form of data, and that form of data would require different kinds of methods. So one important way that people have learned about and made progress in any one field is just to import ideas from another field. So I mean, that's all Einstein did, basically. Oh, that's an overstatement. But that's basically what he did, right? Took some math from one field, applied it in another field, and then went like this for a while. Okay, don't quote me on that. But that's worth doing. You know, there's so many methods out there being developed in so many fields that you just can't, you know, that picking them up in these different fields is really valuable. So last year I gave a talk in a department at Harvard where I have been for 30 years as of 2 weeks ago. And I gave a talk in this department, and I was not aware this department existed until I gave a talk in it. It was the Department of Pharmacoepidemiology. I didn't even know about it. And what were they doing? They were basically running the same kind of analyses that I've been writing about, right? But they had different kinds of approaches, and understanding their approaches is helpful to take back. So maybe an answer to your question is, go out 2 steps beyond what everybody's getting trained with in your one field, and go take a course in political science or in sociology or in public health or in some other field. Maybe that's the answer. Okay, you asked 2 other questions. So Google flus, well, it's a Google flu shows in Crimson Hexagon. So for Crimson Hexagon, I told the story about verbal autopsy leading to the social media thing. So the social media thing was the thing that led to Crimson Hexagon. So if you go get their services, you can buy them, and they'll appreciate that. I will appreciate that too, by the way. But I did convince them as a side point to have a social impact grant program, basically. So if you actually want to use their services, you don't have to pay what Starbucks or Coca-Cola pays. There's just some little fee. So that's the side point. And what you'll get there is the basic stuff that we came up with originally, where you would decide what your categories are. You provide some examples of social media posts in each category, and then it will monitor from then on the percent in each of those categories over time. But it has, Crimson Hexagon will now do all kinds of other things, like suggest what categories are of interest. It has something now that you'll type in some phrase and it will instantly, like in less than 1 second, give you all kinds of analyses, guessing the kind of analysis that you would want next, and all kinds of other things. Okay, and your last question, which you conveniently posed first, was Google flu. So actually, what do you do about this? So I'm working on that. So with another very large company that is in the tech sector, that's not Amazon or Facebook, or Tesla. Let's see, you'll guess it. And they also have a big search engine, but it's not Google. And to me, the right way to do that project is you start with the sick people, and you see what their search behavior is. What Google Flu did you actually explain what they did? Right, so they searched 50 million terms to see what correlated with their time series. What I think you want to do is really connect it to the data. And you see how actual people search, and then you see how people with the flu search, and then you see what the differences are, and you do some kind of analysis where, again, we don't care about classification, we only care about the percent in those categories. So that's what we're trying to do. We've been at it for 2 years, so it's hard. So we haven't figured it out yet, but we're making progress. So.
Yeah, thank you for the talk. Before coming here, I was in Montreal in a psychological methodological workshop, and I have asked myself what I'm doing there. And they talk a lot about anchoring vignettes method.
Oh, they were?
Yeah, so
that's great.
So I want to use those methods to understand or to measure empowerment, women empowerment in Southern Africa.
Sorry, to measure what?
Women empowerment.
Oh, yeah, okay.
Women autonomy in Southern Africa. Do you think it's a great idea, or where can I find some resources to do something like that?
Yeah, absolutely. I mean, I think that's, I think that would be very valuable. Absolutely. I mean, there's intercultural incomparability across different countries, as like the example I gave, but also within a country for different genders and for different parts of a country and for different races and for rich people and poor people. And it's getting people to understand each other, that they mean the same thing in the same family, as I said, is difficult. Doing it across these different people with very different perspectives is really hard. So there are other approaches, and you should use them all in a sense. Cognitive debriefing, and you ask. Have you ever done this thing where you take a commonly asked survey question, administer it yourself to people, actually seriously administer it to people, and then say, hey, what did you think? And then ask like 10 questions, and then say, hey, remember question 1? What did you think I meant by that? It's the scariest thing you'll ever do. Okay? A friend of mine in graduate school did this for the party ID question, which is the most common, biggest question in political science. And she was so shocked by that, she's not in political science anymore. So, but there's a lot of approaches. But yeah, absolutely, I think that would be valuable to do. Really nailing that, getting that right.
So 2 questions. First is, how do you organize these gigantic field experiments? How do you get the politicians in? How did you get the media in to actually publish something that you were planning? And the other one, based on the Restructuring of Social Sciences article, what are the next things after that article? Because I think that it's already like 2 or 3 years old.
Yeah, that's true.
So what's happening?
So let's see, what's happening? Well, so I still run this institute, the Institute for Quantitative Social Science. There's now a movement, basically, which sometimes is called data science, where there's inside each of the social sciences, there's a subfield of methodology. Then there's statistics and computer science and some other fields. And all of these little like sociological methodology and political methodology and econometrics and biostatistics and all these little subfields are all talking to each other. And there's this sort of revolution stirring. We have a seminar we call it Applied Statistics, with which is a tour of Harvard statistical innovations and applications with weekly stops in different disciplines. That's how it's built. And we have an astronomer coming one week and a political scientist coming the next week, and they're all talking about data science stuff. And we can all talk because we have the same rough notation. We can translate stuff into what the models were, and we can figure out what each other's applications are. And we all have the same sort of healthy disrespect for the substance. That's a joke, but obviously you need to deeply understand the substance, but it's the methods that we were all talking about. So that seems to be the movement that we're going to. Sorry, what was the first question?
How do you organize this gigantic?
Oh yeah, so this was the media experiment.
Media and the politically robust things. How do you get those?
Yeah, so in each case, it's a work of politics. I said in one of the articles, this is a work of political italicized science and a work of political science italicized, right? And it really is both. Like you have to get the politics right. So in the media experiment, there were media outlets that we recognized wanted to figure out their impact. Because if they knew they were having an impact, They can get more money from their funders. They can convince their readers to give them money, right? It matters to them. We then had to convince them that the way to measure their impact is not to just claim they have an impact, and not to just look at it, right? Not to look at their bottom line, but to run an experiment. That was hard, right? Because they had to like have the patience to deal with us, right? And we had to understand their language as well, and what they cared about and what was important to them. Like we would just say, look, for the importance of the science, we have to randomize. So we're going to randomly tell you, we're going to tell you what to write, and we're going to tell you when to write it. If you say that, conversation over, okay? Because they start using, I realized in these conversations, it took 3 or 4 years to begin the experiment, okay? As soon as they used the word journalistic integrity, I knew it was over. Like I knew they had to start over from scratch, right? Because that means, journalistic integrity means that the journalists get control over what they publish and no one tells them what to publish, right? So how is it that the journalists can have total control over what they publish, and in our article we could say the journalists had total control over what they would publish, and at the same time in the same article I could say for our scientific readers we had total control over what was published. That was the design solved that political problem, right? Right.
And it's an encouragement design?
No. What we did is, well, we first got on the same page and we explained to them why we actually needed to randomize. They understood that, but they couldn't just let us choose, right? Or choose the subject area and things like that. So we found a mechanism. There's a mechanism that is used in journalism now. So we found something ordinary. Right? And the mechanism is that there's several organizations that want to go after something. Do you remember the Panama Papers? So Panama Papers was a leak from a high-end law firm that that helped people save tax money. And save is a very generous word. Okay, and a bunch of journalists figured this out and realized that to go after this, it would be better to combine forces. So they assigned what they called a project manager, which was somebody at one of their places, not an alternative editor, that would not be valid, but a project manager. They stayed on the same page, right, about what they were doing. They divided up the task. Different people would publish on different subjects. They'd all agree to this. At the end of the day, the project manager gets to decide whether they're part of the project, and each of the individual sites gets to decide whether they're part of the project. We choose a policy area. We say within this policy area, we're going to choose a group of outlets to publish. They can volunteer. So we have 4 or 5 outlets. We put them in the thing. We then let them have total discretion on what the article is within that policy area that we chose. So they're making a choice. And if they make a choice outside the policy area, we say, fine, you can publish on that, but we're not including that in our experiment. So they have total control, and we have total control as to what's in our experiment, right? We figured out how to say these things in ways that were compatible for both sides, right? And then we only chose topics in which it was okay with them if it was published in week 1 or week 2, right? That's not every, if they're going to write about something Trump did yesterday, that's not going to qualify. But there are many things that may work. They knew that was it going in, and they were only going to be in the experiment if it was okay to publish it in week 1 or week 2. If they needed to publish it in week 1 and we randomly assign them to week 2, they're allowed to do that. They just wouldn't be, they wouldn't be part of our experiment, right? I mean, unless they did it after randomization, in which case we had to include it anyway. But, we stayed with really, really good communication. We worked really hard on it, so that just didn't happen. But that was the basic politics of it. The Mexico project, we came up with the following design. So normally in a classic completely randomized experimental design, you take each subject and we flip it in heads, okay, you get the medicine. We flip it heads, you get the medicine. Flip it heads, tails, you get a placebo, okay? So that's a completely randomized design. We take the heads, we put them there. We put the tails, we put them there. The 2 groups differ only by random chance, okay? Now let's suppose that in doing that, you had enough political power to move from the placebo group to the medicine group. You just went out, you messed up the experiment, right? You convinced the doctor who was supposed to assign you to put you in, and so we have one person that, now you'd say, that's not a ruined experiment, that's just one observation. Now you're making assumptions. The point of the experiment to begin with was to avoid modeling assumptions. And now all of a sudden you have to assume that this one observation is not going to be a big enough outlier to ruin the whole experiment. Everybody see? So how do you get around that? And also, we were worried about that very thing because the politicians would come in and mess with the communities. Our unit of analysis was the community. So what we did is we chose a matched pair randomized experiment. So we'll take two people that are identical, right? Matt and me were exactly identical, okay? In all respects, we were cloned at birth, okay? We do the same thing, right? And you flip a coin, okay? And heads, you get the treatment and I get control. And tails, I get treatment and you get control, okay? Now, why is that better, okay? So there's only one coin for the two of us rather than two coins. The reason why it's better, well, first of all, why does it make sense? It makes sense because we take the treated units and the control units. Now we have two groups, and they differ only by random chance, okay? They also differ even without the random chance. They also are the same, they are the same because of the randomness, but they're also the same because we matched ahead of time, right? So a not silly example is let's match on gender. We'll take two males and flip coins and put them here or here. Now we'll take two females, flip coins and put them here or here, and keep doing that. And at the end of that process, with 100% certainty, we have the same number of males and females in each group. Everybody follow me? If we were flipping a coin for each person, we would not have that. Okay. So what we get from this is certainty on the variables we know about of exact balance between treatment and control groups. We're avoiding the problem of having all the healthy people receive the medicine and the unhealthy people not receive the medicine. So on the variables we know to match on, then we can match on, we get exact balance. So that's better than randomization, and it requires fewer observations. And in fact, we proved that our standard errors could have been as much as 600 times larger if we flipped one coin for each community than for each, right? And we were running an experiment that would probably never be run again, ever, right? And I was spending an enormous amount of money of the Mexican government in order to try to make the people of Mexico healthy. I did not want to, I was okay with the program we were evaluating, being judged a failure. That didn't bother me. I was not okay with the program evaluation being judged a failure. That would have been bad, right? I was not willing to deal with the possibility of the two groups that we would randomly assign one at a time to just, by chance, happen to be very different. That would not be a good thing. I didn't care about, on average, across experiments. This was the only experiment we were going to do, right? And then in addition, we had the other advantage. Suppose Matt gets control and I get treatment, and the politicians come in and for Matt's city, they give him money anyway, right? Or they give him health care anyway, okay? What happens? We know about that. We just drop Matt because he just got dropped out by himself, and we drop me. And all the remaining pairs are still exactly balanced on the variables we thought to measure, and balanced with respect to chance on the variables we didn't think to measure. Whereas if we did it person by person, we wouldn't have that advantage. As it happens, so we wrote this article on the politically robust, et cetera. But you actually need more than that. You need to prove that this is a good thing. And Kosuke actually was part of, Kosuke, you're not all Princeton people. He's in your politics department. And he was involved in proving that all the public health people that came before us that said match pair experiments are no good for all the following reasons, we had to prove that every one of these reasons was false, which we did. So anyway, that was a different paper.
You have such an incredible variety of projects, and I'm just kind of wondering, how many didn't make it up on the board? As in, how many did you have to give up along the way? When do you just decide that experimenting with a new method or a new area is not going to work out? How much do you tenaciously stick with things until you can get something out of it?
Well, every day that you decide to work on something, there's all kinds of things you could work on, unless you're working on your dissertation, which is like the worst time in your life, okay? Where you really either work on one thing or you feel guilty, and those are your choices. It's so much better when you get out, okay? So that's what I do. I just choose, and the idea of proposing to work on something and then working on that to come, I don't know what's going to work out. I really don't know what's going to work out. I try to work on things. But how long, one way to phrase your question is, how long does it take for a project to come to fruition, right? So my range is 1 day to 8 years. Okay? so 8 years was a paper that I worked on. It was ecological inference, and it was a paper on who voted for the Nazis, basically. The title was Ordinary Economic Voting Behavior in the Extraordinary Election of Adolf Hitler. I really liked that paper. It was really good. It has it has amazing similarities to a recent election in the United States. Forget the candidates, okay? Just like who lined up with whom. And then one day, I was an assistant professor, and I woke up in the morning and had this idea. And of course, I've been working on all kinds of things before that, so you don't just do one paper all by itself. But I just had this idea. I went to the library and I wrote down all these numbers, and I came back to my office and I typed them all into my computer, and the analysis worked. And I had this new method from this other paper that I had published, and I tried it out and it worked exactly as planned, like on the first run. And I spent the rest of the day writing it up, and I sent it out to the journal before I went to sleep, I swear, okay? And it was accepted, okay? That was ridiculous, okay? That will never happen again. So that's sort of like the range. You sort of never know. And that was sort of really cool. Like, I'm glad I did that because it was a fun experience, but I wouldn't want to do that every time.
So actually, I would like to learn more about your experience as an academic entrepreneur. So you mentioned Crimson Hexagon, but there are as well other companies that you co-founded that are successful. Is it something that you actually encourage your students and academics in general in computational and social science to try to pursue their projects beyond academic contributions and try to commercialize them? And if so, what do you see kind of the risk and benefits of doing this at the different stages in someone's academic career?
So yes, I think more and more, I think we almost have to. So it used to be that all the data in the world was created by us in the university. And now almost all the data in the world is out there in the private sector. Like almost all of it, right? A very small fraction. We do create really important data, but it's such a tiny fraction of all the data. So in order to study the world, you have to actually go visit the world, like more and more. And one way, and so that's one answer. You have to at least pay attention to the commercial world. Another answer is, what's our goal? Like our goal, roughly speaking, in the university is the creation, preservation, and distribution of knowledge. If you need to explain to your parents, like my dad would call me up and he'd say, okay, tell me one more time, what is this political science thing? And I would try to explain to them. But that's what we do, right? The creation, preservation, and distribution of knowledge. If something gets commercialized, that's a really good way of doing all three. And then it turns out that there's other tremendous advantages. So like I wouldn't have been able to do the China studies I talked about without Crimson Hexagon. And there's actually a bunch of other studies as well that we wouldn't have been able to do without access to the data that makes it possible. I find that I can hire people inside a university that no company could ever hire. Brandon, for a little while anyway. And then there's people in companies that they can hire that I could never hire, you know? But the flow of information back and forth between the two is way better than either one separately. So I really think that's valuable. And I also find it really fascinating. I've done Crimson Hexagon, and I mentioned Perusal, and I've several other of these ventures. You know, you want to do it in an incentive-compatible way. You know, you should finish your dissertation. You should get tenure. There's plenty of other things to optimize, and this is yet one more to do. But if you find the right opportunity, it's sort of another answer to your question, like what is it, like is there the right opportunity where you don't have to put too much time in it, you can still do the other things you're doing and make more opportunity, then that's a really valuable thing. So, it's good, I totally encourage it, and it's completely fascinating. Actually my model is I find a CEO, so I like my day job, you know. So let me just say one more thing about this. So a startup company, roughly speaking, 15 things have to go right. Like if 15 things go right, like they're billionaires. And if 14 things go right, they're bankrupt. Right? So that's a fascinating intellectual question. Right? And any one of them, it's not like right, wrong. It's like, okay, your choices are 1 or 2, so now make a choice. And your choice, the choice you can choose might be giraffe. Right? And it's like you completely change, like I was talking about earlier, you completely change the question. So it's a totally intellectually engaging thing to do as well. and productive, and data comes back, and so sorry, who's going to ask a question? Somebody over here.
Yeah, I guess I do a lot of work with books and digitization and scanning and stuff, and just the book as a unit. So I would just be interested in hearing more about like perusal, and maybe specifically like how you integrate the books that you have on it.
So the way it works is you assign your students reading, and you say read chapters 3 or 4. But instead of getting the book, they go to perusal, and they see what looks like a PDF. It's not actually a PDF because it protects the intellectual property of the publishers. So, but it looks to a user, it looks identical to a PDF. You couldn't tell the difference. And the assignment is read these chapters and annotate the chapters. So what does that mean? Through a particular rubric, you just put some annotations in there. Socially, collaboratively. Okay, you can sort of see your friends when they're reading it. You can turn all this stuff off, but you can see it. So if you don't understand an equation, you say, I don't understand this equation. And your colleagues in class can respond Facebook style in threads to the initial annotation. The goal you're given to read the chapters and also to annotate. Okay, if you want, there's a grading element to this. So the instructor will say, I don't know, 15% of your grade is your reading, and then perusal will totally handle the 15%. Okay, so it will grade the annotations automatically, better than you could as an instructor. Better because as an instructor, if you're going to read the 20,000 annotations your students would make, you would die of boredom very fast. Okay, and our algorithms don't seem to die. So we can grade them very well on the basis of how engaged they are in their content. So not just ephemeral stuff. Okay, and then also we know everything the student does, absolutely everything. Overbearing, big daddy, big whatever it is, big father, whatever, bad stuff. However, the rule is that all of this stuff is used only to the advantage of the student. So the idea, we think of it as non-adversarial grading. So adversarial grading is like that quiz, and if you read closely, but you sort of fell asleep during, between page 43 and 44, gotcha, none of that in perusal. In perusal, if you sleep through pages 61 through 67, or you skip over it, we know that. And you'll get a private, non-humiliating note from perusal that says, you skipped over page 61 to 67, that's fine, but on page 63, your fellow students found a particularly important concept. We think you should go back to that. It's on the bottom left-hand side. Right? And so there's things like that to help you along, or if the instructor establishes, uses the grading from the annotations, it'll say, you can get up to 15% of your grade from perusal. It'll say, you haven't quite done enough, and they're not quite enough high quality. If you put the time in now, you'll get to that 15%, right? So it's sort of that kind of thing. And then as an instructor, it's really useful because it actually works better if you don't get involved outside of class. You just leave that to completely automated. And then, just before, if any of you walked into class and said any questions, what do you get? Docus, right? You don't get anything, okay? So what do you do about that? So what you can do in perusal, I used to do that and demand that somebody ask a question, but people just tromped across campus, they put their stuff down, they're preparing to be entertained, So now we push one button, it's called the Student Confusion Report. And it gives you one piece of paper, you print it out, on your way to class, you read this, it gives you the 3 or 4 things that students were most engaged with or didn't understand, and as you could see today, without even preparation, you can explain those things better, and those are the important things to the students. So you actually have something useful to do right at the beginning of class, instead of just asking questions they don't want to answer. So that's the basic idea. There's other kinds of engaging things.
So I wanted you to follow up a bit on the point you had about restructuring the social sciences. So I'm very glad that you are trying to do that, but there are a lot of people who are very happy with the current structure, especially those on hiring committees, right? Not everyone can be as enlightened as Matt and Chris here, right? So, for all of us, you certainly fought and won a lot of these battles. I mean, how do you get people along, who are just perfectly happy with Excel macros and all the rest, and we just look like a bunch of pulling rabbits out of hats, right? How do we do this?
First, we get them all to use perusal, and they'll all be better people for it. Okay. So our particular, I'll just tell you main part of the story. So, well, I don't know, it depends what question you're asking. I don't quite know what question you're asking. So here's a series of questions. Here's a series of questions you might be asking. So what did we do at Harvard, right, to create IQSS, and why, and what was that thing? So that's one story. Another story is, well, what's the big changes and what's going on now that we should all pay attention to? And maybe the third story is, how do we make sure that everybody in this room gets a really good job? I'm just joking. But maybe which one of the, like,
how do we have a marginal improvement on the field? How do you know, not everyone's going to like learn Python and R, and they'll be our colleagues. Like, how do we communicate, you know, the things we're trying to do to people who are not eager to like pore over coding? Like, how do we integrate our research with the traditional normal science that isn't yet restructured?
Okay, so the restructuring thing, just so you know, was about changing the organizations inside the university, right? Like centers and institutes and things like that. So that's a little separate from your question. So I'm just going to put that
right.
Right.
Yeah.
Okay. So you're asking a political question. It's actually not. Which means it's an important question. I'm a political scientist. You're asking a question that's not actually different from the how the heck did you do that Mexico experiment, right? Or the media experiment, right? So when you do, you know, pretty much anybody that is in one field that writes something for another field has to deal with the culture, like it's culture shock. In fact, in your own field, I'd say most people that graduate, they graduate with all the methods and the substance, and they've got a PhD from a great institution, and they have learned all the methods. They know how to write. They know how to do all the things they do. They get to their assistant professor job, and they write up a great article, and they send it to the journal, and it is summarily rejected, often with like comments like, "This is inane," right? I mean, why? And they're all like completely shocked. And the answer is, like they said, "But I thought I knew the methods. I thought I knew how to do this." The answer is they did. They knew how to do all those things, but they didn't know how to resonate with their audience. So the one thing you do going from graduate school to a successful academic is you turn from a private person into a public figure. And that's a weird thing. So in school, you write for pretty much one person, and you all know exactly how to do this. You look at the person very carefully when they're writing. You know, when they're lecturing. You know what they care about. You know what they're interested in. You know how to write the paper to get the A. Otherwise, you wouldn't be here. Right? Okay. Now imagine that instead of that person being the grader, instead we're going to randomly select 3 people from, you know, who knows what population. Holy cow! How do I write for them? Right? That's the failure. It's the failure of politics. It's figuring out how to write for an amorphous audience. An amorphous audience, by the way, who is anonymous. People who are anonymous are assholes. Okay. When you drive, people cut you off. When you walk down the street, how often do people cut you off? Right? I want to forget driverless cars. I want cars with a hologram of your face above the car, and then everybody would drive very politely. Driverless cars would be good too. So figuring, I mean, so I don't have any answer to your question, but that's the question, right? It's how to resonate with your audience and how to figure out who your audience is and figure out what they care about. And that's politics. It's the job of a politician trying to appeal to a very large number of people. It's not like a job of a politician. It is the job of a politician because that's what you are, right? So now that I made the answer harder than the question, I mean it's hard, but that's the position we're all in. And you know what? It's really hard at first, and later on, it's really hard too. You know, it really is. Like every time I try to write in some different fields, and often in my own fields, you know, like I never would have guessed that people would have made that mistake. You know, of course, when they misinterpret your paper, that's your fault. Tie doesn't go to the runner. You know, it's always your fault. So that's the, you know. I have no hope there. Yeah.
Hi. I have a question about causal inference and the discipline of political science. And I'd be very curious to hear kind of your perspective on the future of political science and whether you think that good political science in the future is going to require causal inference or causal claims, or whether there's room for high quality political science that doesn't necessarily make causal inferences.
So I want to make sure that I understand what you mean. Sure. So give me an example of political science that doesn't make...
Like a descriptive claim.
Okay.
Very high, accurate, high quality descriptive claim.
Okay. So I think the answer to the question is purely cultural, right? Because it's like what we can convince people to say is important, right? And in the social sciences, we usually care about why stuff happens, not only that it happens, right? And not only that, how it happens, right? I always bother my physics friends because they only study how things happen. They don't know why stuff happens like that in quantum physics. They don't even know why an object at rest tends to stay at rest, right? They just know how it does, right? We tend to ask that question. Now, why do we tend to ask the why question? Because that's our cultural norms, right? That's what we do. If you could, so let's come up with an example of a descriptive claim that would be really valuable. Okay. Well, I'm just thinking of course, my work. The Social Security thing where we said the Social Security Administration is forecasting badly. That was, in a sense, a completely descriptive claim. What people are dying from in developing countries is a descriptive claim, and what people think on social media is a descriptive claim. So I think whether you can convince people that that's important. The reason I asked you for a definition was I was wondering whether you were asking a quantitative question. You're just asking causal versus descriptive. So I think it depends on whether you can change the question enough so that it could be of interest to people, right? In public health, I've always found this interesting. For them, they can write an article that says, I've estimated the rate of AIDS among sex workers in Bolivia, and then publish that. And that's actually interesting, because that's a percentage number, and it actually has important implications, right? And they don't have to say why. And that's the norm of their field. Usually we want to know what a story is, But we could come up with examples of descriptive questions that I think we could convince people to publish because the fact of it is really interesting. And I think you just have to make the case, right? So some of this is how do you make a case that something's important, right? I tell my graduate students, we could take a dissertation that's methodologically great, okay, and boringly described, and rewrite the title, abstract, and the first few pages of the introduction, and the life career trajectories, or at least the first job of those two people would be vastly different, right? So spend quite a lot of the time when you write articles on the title, because the title, of course, structures the abstract. The title just gets you to read the abstract gets you to read the introduction. But that's a real art form, like getting those right. And that's more of the answer to your question than whether it's descriptive versus causal inference. It's whether what you're doing is important and whether other people would believe what you're doing is important. Tell them it's important, because if you just tell them, they will be more likely to believe it. We know that from psychological experiments. But then try it out on them. Try it out on real people, like your parents or siblings or whatever it is. Try it out on your graduate school colleagues. Get to know each other. This group should stay in contact for the rest of your careers, because you really it's really important that you have other people that will read your work. Not only the methods, but also just why is this important? Even the people, it's really cool to have this group, this diverse group of intellectual interests, because you can have people outside your field, but sort of with the program, read your work, and then you can say, I don't get why this is important. And they'd say, no, it's obvious. Everybody in my field knows that this is important. And you say, but you haven't explained it to me. And if they haven't explained it to you, there's probably some people in that field that don't get it either. And even if they do get it, and they know it's important because of something else, they don't know it's important because of this article. And so figuring that out is the answer. Is sort of the answer.
Do you mind if I ask a quick follow-up?
Yeah, sure.
So I didn't have the quantitative-qualitative divide in my head, but as long as you
But
brought it up, I'm curious about what you think about what the future of qualitative research in political science is, and if it has a future.
So of course it has a future. Basically 100% of the work in the social sciences is qualitative, and some fraction of it is also quantitative. That's the way I would think about it. I do think, however, that the divide between the quantitative and the qualitative folks is slowly going away. And what I mean by that is that the qualitative folks are collecting massive amounts of information, typically about smaller stuff, right? And that's very valuable, okay? But it's not as generalizable, but it's smaller stuff. But they're collecting a lot of information. They have thousands of pages of field notes. Did somebody do automated text analysis here? They have audio tapes. They do videotapes. We now actually recognize this as data, right? And so we can actually help them, and they would actually like our help, and they actually know more about any of the datums than we do. And so more and more, actually, I see these partnerships going along, rather than there basically being two warring camps that when you win, I lose. So that's my sort of hope for, that was the point of this book, Designing Social Inquiry, that the standards are the same in both, and to put everybody on the same playing field and get them to talk to each other. So that's what I think that the future is, or should be anyway. So.
I was wondering if you could talk a little bit more about forecasting. Do you focus more on like the point estimates when you're trying to predict like Social Security like 25 years out? Is it a story of variance? Like, how do you kind of communicate the story when you forecast?
Yeah, so I can't actually talk with water in my hands because I'm going to spill it all over you guys, or myself. So we were evaluating their forecasts before we made our own. We also made our own forecasts, but when we were evaluating their forecasts, they had different kinds of uncertainty estimates. One kind of uncertainty estimate was no uncertainty. That was not a particularly good method of uncertainty estimation. Another was they would say, here's our high forecast and here's our low forecast. And so we evaluated not only the point estimate, but their range and things like that. We found they got, after 2000, they got more biased and more confident of their answers. And they got more confident of their answers as they forecast a year closer into the future. You know what I mean? When they forecast farther into the future, they got less confident, as you would expect. When you're forecasting only a few years out, they would get more confident, but of a wrong number. So that's not very good. So yeah, I mean, our forecast should always include uncertainty, right? with the program. If we can get the point estimates right, that's pretty good. So.
Folks, I think we should give Gary a rest. He's been talking now for 2 hours.